Hi everyone, I'm Colin Penty. My pronouns are he, him, and I'm the Studio Technical Art Director at the Coalition. And so today I'd like to talk about visual tech exploration we've been doing using UE5. Here are some of the topics I'll be talking about today. I'll be talking about our alpha point demo, our character rendering tech test video, and our cinematic visual tech test, and just all the learnings from these three demos, all in Unreal Engine 5. So what were the goals here of Alpha Point? We essentially wanted to figure out how we were going to build these high polygon meshes that were much higher poly than anything we've done in Gears 5. We needed to implement a new base material and texture pipeline. We were kind of going to a clean slate more or less with UE5. How can we modify the engine? So we ended up adding two mods to the engine. We added convolution bloom optimizations and visual effects G-buffer with Niagara readback. We wanted to evaluate megascans. How can we incorporate this into our workflows? Wanted to evaluate Nanite and Lumen and UE5 in general, of course, and then measure this on Xbox and how does this perform? How does this fit in memory? And yeah, kind of dig into any issues we may find there. So some disclaimers here on the Alpha Point demo. These assets were just built for this Alpha Point visual tech test. They do not represent any games currently in development. This demo was actually made to be seen internally, and then later on we decided to release this externally. And 90% of these assets are built by the Coalition, and about 10% are Megascans. This is all captured live off Xbox Series X. And none of this is really representative of final frame rate targets or input or output resolutions, but it's pretty neat. So without further ado, here is the Alpha Point visual tech test. Enjoy. Okay, great. I hope you enjoyed that. So yeah, here's some early work, some inspirational images we put together for the scene. Keswick Allen, the lead artist, sort of put this together to kind of get a feel for the art team of what we would be executing on. This also helped tech art kind of figure out what sort of materials would we be building and what kind of lighting are we dealing with. Here's some early sculpts and gray boxes of the level. You kind of see how sort of simple it was in the early days. Sort of a midpoint screenshot where there was a little bit of sculpting into the level, but nothing much else. We had just the ground and pillars. It was all about this idea of technology meeting kind of ancient ruins and how would that kind of look. It creates a cool aesthetic. So some technical stats here. We began this demo actually in Unreal Engine 4 before we even had access to UE5, though we knew it was going to be in UE5 eventually. And it was funny, it was running extremely slow by the time we were switching to UE5, where the dense geometry was slowing down the editor and the artists were complaining. And switching to UE5 was just fantastic to get Nanite running and to have just that acceleration that Nanite brings. Really helped us finish off this demo. And yeah, we're outputting at 4K. using the new Temporal Super Resolution that's in UE5. And in the input resolution is somewhere in the 1080p to 1440p band. And you'll see later on there's some comparisons of kind of the quality differences, but it's TSR does such a good job of upsampling that you can go fairly low on the input res. We had over 100 million triangles in this scene. And yeah, we have lots of technologies in here, such as Nanite, Lumen, the new virtual shadow map system, virtual textures, temporal super resolution, convolution bloom, and others. So high polygon modeling findings. Modeling assets at this sort of level of quality can be time consuming. We do sort of find it takes maybe 25 to 50% more time. So it's good to have more upfront planning. Reuse is key. Good concept art really is valuable than before. Since all details are sculpted now instead of in a texture, attention to scale is really critically important, we found. So it's really harder to correct a modeling scale issue after the fact than it is a texture scaling issue. So we did kind of come up with a workflow of rough sculpting. So we do a rough sculpt just to align the team and ensure scale before doing the detailed sculpts. And we did find with Alpha Point, going over 1 million triangles can be challenging with the DCC tools, but more on that. So Alpha Point, the average triangle count was 300,000 to 500,000 triangles. This is 15 times your average Gears 5 asset, so already quite high. The assets all did have normal maps. And so certain workflows were just painful in tests going over 1 million triangles. So DCC would slow down a lot. UV editing was really challenging in DCC tools, going over 1 million triangles. Importing into UE5 can be a little bit slower, but it's fine. So since Alpha Point, we have improved our next-gen workflows, allowing us to go to higher triangle counts than the Alpha Point triangle count, so 300 to 500,000. So I'll speak about that now. So we are now building models higher than 1 million triangles quite often. Do we go up to like 5 million triangles? No, not usually. That starts getting quite heavy. But I kind of like that 1 million to 2 million triangle band. One big discovery was using Rhizome UV to help with the UV unwrapping. That's really accelerated the UV unwrapping of high triangle meshes. We've since upgraded the whole team to whole art team to RTX 3080s, which has definitely helped with the high polygon modeling. And we have also switched to a layered mass tiling material. So basically we're layering in different material types with mass, and this has allowed us to save a lot of disk space as we're not baking out a lot of per object textures. We've created a Boolean set for subtractive Booleans for stone objects. So we just can give this Boolean set to, say, an outsourced vendor and say, use this to do subtractive Booleans to create the shapes and damage and wear and tear on these stone objects, for example. We have a damage mask, an AO map, and a macro color mask that we are baking out for all of these assets, but they can be lower resolution, so it's not as much of a memory sink. And we are leveraging Substance Painter Smart Materials and Smart Masks to kind of generate a lot of these masks and materials that we're using now. So these are all sort of more recent learnings post Alpha Point. So for Alpha Point, vines and foliage. So reminder, Nanite doesn't support translucency, mass materials, the spline tool, pixel depth offset, vertex colors on actors, or world position offset. So you have to be sort of strategic with how you use Nanite assets. So in this case, our vines were generated using the Blender Ivy app and are all Nanite. This works out for vines, given they're not really high frequency foliage. The grass in the level was mostly non-nanite as a result of the alpha constraint. We wanted to have the grass be masked, and this also allowed us to use pixel depth offset to blend the grass into the stone tile a little bit. The downside of using non-nanite for the grass is your base pass does slow down, and then your shadowing slows down as well because you don't get the nanite shadows. So you have to be, again, strategic about what is not Nanite as well. And Epic has said Nanite is not the best use of extremely detailed foliage assets like trees or grass. It might change in the future, but for now, that is not recommended. And you can see the overdraw view here as well. So decals, we did leverage a lot of parallax occlusion decals. This allowed us to fix seams and crashing geometry, as well as add additional details. They have all the same sort of inputs as our base materials. We can do tinting, detail maps, macro maps, parallax occlusion mapping, and then recently we've just added relaxed cone step mapping as well. And this is a function we had on Gears 5 that I spoke about years ago in Unreal Dev Days in 2019, but basically relaxed cone step maps allow us to have that depth that parallax occlusion mapping has, but it's much cheaper and doesn't suffer from the stepping artifacts that parallax occlusion mapping suffers from. And again, a reminder, strong decal workflow, more important than ever with Nanite, right? Because creating these layered materials and whatnot, and kit bashing, sort of blending assets in using pixel depth offset, etc., is harder to do with Nanite because some of that's not supported. Our new base material allows up to 4 material layers. We can change blend modes per layer. We've made a hard and fast rule that everything has to be wrapped into a material function for the tech artists and VFX artists, etc., whoever's creating these materials. This allows much easier organization and setup and iteration later. We have clear naming conventions and guidelines. We have sort of a mixture of, per layer detail, micro detail, macro detail functions. You always want to try and texture pack all your macro detail into a single texture that can be sort of lower res, right? We have mass layered materials, especially in use for architectural assets. So these are larger assets usually. And we also make extensive use of triplanar projection mapping for all of our various passes to improve quality. We've created a new TC Texture Toolkit pipeline. This basically allows easy managing of textures and materials from Substance, Megascans into Unreal. It sets up texture references, metadata, categories, tags, interfaces with Perforce. It exports to Unreal with appropriate channel packing setup. We are packing our normal maps in with our roughness and metalness and making that a BC7, just like Gears 5. This saves us, again, on texture memory and allows auto importing into Unreal. So this has been a big win, and definitely recommended you sort of create your own sort of Substance Megascans pipeline. In terms of texture generation, assets in Alpha Point shared the same base rock, color, normal, roughness textures. But we did bake out unique AO, height, etc. using the Marmoset Toolbag 4. And this has been great and quite fast with the new RTX cards. And for Megascans assets, we'd grab the highest poly asset that Megascans offers and then use that to generate the AO maps, height maps, etc. Then we'd create base textures in Substance, Photoshop, or Mixer. And we'd almost always replace the Megascans material with our own for consistency and control reasons. So assets on the left is our material, right is Megascans. So again, it's just sort of to achieve the look we would like, we quite often replace that material. Detail mapping. We have detail maps on everything, and so on Gears 5 it was all about detail normals, and now we have detail normal, detail diffuse, and detail roughness all packed into a single BC7 texture, and we leverage the color curve in base material to give kind of a grayscale diffuse map some color if we need it. And we added a detail map masking workflow as well to have layered detail maps. This can get expensive, but it can be used in a limited fashion. We do have paintable volume fog. So this is building on our Gears 5 technology, which is intersecting height maps to generate sort of these 3D masks in the game world. And we now can have brushes that are arbitrary meshes, so any mesh can be a brush, as you can see here in this video. And the layering system allows stacking and overlapping of brushes, and it's much more responsive than Gears 5. Gears 5, we had to have such a temporal history weight to the fog to get rid of some of the blockiness that we're really leaning into, again, the power of Xbox Series X and Series S, and can we raise the volume fog density, and then in turn lower the history weight to make it more responsive. So if a character passes in front of a light shaft, you can see that light shaft react accordingly. And then we also have improved noise breakup, and you can see that all here. We also have a whole new UI that's not shown here that really allows the artist to layer in this fog, which is fantastic. Layered materials. So with Nanite and UE5, you can no longer vertex paint material layers due to extremely high vertex counts, and Nanite doesn't support it. You can do it on the object in the static mesh editor, but not on the actor. And so we had to come up with a variety of techniques to layer in detail to replace vertex colors, because all of our artists are very, addicted and used to vertex colors from, 15, 20 years of using those. And so things we did in place of vertex colors we leveraged a material up vector, per pixel in the material. You can layer in things like sand and snow that way, or dust. We leveraged decals. We placed a lot of geometry debris, kit bashing. We did, blend non-nanite meshes into the grounds using pixel depth offset, but you want to use that sparingly because that comes with an extra cost, right? And we also had unique mask per asset that would allow kind of layered materials. And we're doing that more and more as the unique mask per asset. We've also created a volumetric material layer painting system that's a work in progress, but it leverages the same intersecting height map technology as the volume fog, and it allows the artist to paint material layers in the editor, and they can paint across objects because it's all in 3D space, this mask, across mesh boundaries. So this has been really powerful. And you can, create many brushes, separate layers, kind of organize it all that way. UI is extremely important in workflow for these sort of things. It does come with some cost. Right now it feels like it depends, but it's like 75 to 100 instructions in the shader, but we are continuously optimizing it. And it seems like there's a bright future for this tech. We do leverage virtual textures. This is not a UE5 feature. This is also in UE4, but we hadn't used these before. Gears 5 did not. This tech didn't exist when Gears 5 was sort of getting off the ground. So this is exciting for us to use at the coalition. And this really allows us to lower our memory footprint of our textures, with a small sort of CPU and GPU cost, which seems well worth it. Let's see. Yeah, we have set up all of our texture samplers to be streaming virtual textures. We do that now on all our textures. They're mainly 4K, no 8Ks at this time. Although if your asset was large enough, I'm sure you'd find a reason to use it. They are more expensive, as I mentioned, because there's 2 texture fetches and some math. So it's important to reuse UVs when sampling textures to reduce the cost. So Temporal Super Resolution. This is a 400% zoom on sort of what the Temporal Super Resolution is doing in Alpha Point. Really amazing results, especially when comparing to the temporal upsampling that Gears 5 used and UE4 uses. This is fantastic. The performance is a measure of the input resolution. So the lower the input resolution, the faster everything gets, which is flipped around from the way temporal upscaling worked in UE4. But that's great. So yeah, you can see at 1080p going to 4K, it's 2.23 milliseconds. And that's without separate translucency. You enable separate translucency. TSR gets a bit more expensive. So these days the cost is a little bit higher for us, but overall the results are fantastic and really subtle, if not imperceptible, difference when you go from 1440p to 4K versus 1080p to 4K. And Epic generally recommends 1080p as sort of the resolution of choice for UE5. And so you can really see around the grass blades and such here. I believe there's a few more comparisons here. So you can see 1440p to 4K, 1080p to 4K, and this is using the 1440p to 4K is using the Gen 4 upscaler, which is the the Gears 4 temporal upscale, so not as powerful as TSR. So you can see here, what I was basically trying to show here is that 1080p to 4K using TSR looks better than 1440p to 4K using temporal upscaling, which is kind of what Gears 5 was generally doing. And then a final comparison, native 4K to 1080p going to 4K. And again, very, very subtle differences here. So Lumen quality. So the scene does use Lumen, and we use virtual shadow maps. And when you use Lumen, you get Lumen reflections and Lumen indirect. And we're overall quite happy with Lumen visual quality. Huge quality of life improvement, obviously, to the artists that don't have to manage UVs anymore, or light bakes, or really like the checking out of the levels and being able to save the levels. That was such a pain on Gears 5. You know, there's some small visual pain points, but these are getting resolved rapidly. So things like some semi-rough reflections can be a bit noisy. Sometimes there can be a little bit of a draw in of the indirect on a camera cut. But that only occurs if you have a light far away that you're cutting to. Lights in the immediate vicinity should retain their indirects across camera cuts. And there is an AO flickering around high frequency assets like grass blades, but I actually just was informed by Epic that that's been resolved in newer versions of UE5, which is fantastic. Lumen performance, yeah, overall Lumen performance is quite absorbable at high quality for a sort of a next-gen console game at 60 FPS. For 30 FPS game, you could go to Epic quality, and yeah, really there's probably like a bespoke tuning here that you'd want to do on your next-gen console game of tuning the reflection resolution versus the indirect quality. There's just dozens of parameters you can tune. But you can see here, I was trying to distill it down to basically high quality here on an Xbox Series X at 1080p is 3.5 milliseconds, and Epic quality is about 6 milliseconds, which is just a little bit too much on a Series X, but for a 60 FPS game. So yeah, liking high quality and kind of where that's landing right now. And Lumen reflections, it's again really fantastic to have this just handled by Lumen, and you don't have to deal with RCAs anymore, which was a big thing in UE4, right? Reflection capture actors, you had to manually place them, and but in software, basically it reflects the sign distance field mesh representation of all the objects. And if you use hardware ray tracing, Lumen reflects the proxy mesh of Nanite. And I'll talk a bit more about that later. And then on top of all that, it uses a screen trace, which is basically like a fancy SSR that gives you additional detail. Like you can see here, all the particles are reflecting in the water, things like that. The one thing I have observed about Lumen reflections is the cost is very variable, and so you do need to be careful about max roughness cutoffs and things like that, because the cost can get away from you if you're looking at a very shiny wall or something like that. So it's a lot more variable than, say RCAs were on Gears 5 and UE4, but it's worth it for the quality, absolutely. Virtual shadow maps, another new key tech in UE5, and yeah, it's basically a virtual texture that's basic. All the shadows are being drawn into and looked up in, and it creates per pixel shadow detail that is very close to ray trace shadow quality. It's fantastic. And so you can see here the detail, the on and off, just the amount of detail you get on the bricks and the grass when you go to virtual shadow maps is phenomenal. It also has sort of a contact shadow inside of it to fill in details that might get lost. Yeah, really love virtual shadow maps, and they continue to get faster as Epic improves performance of them, and so they're becoming more and more viable. Interesting thing about virtual shadow map performance is initially in Alpha Point, I had a bit of a heart attack looking at the virtual shadow map performance. I was like, what's going on? They're taking 6.3 milliseconds, and quickly noticed that a lot of our non-nanite assets that were quite large, such as like ground, dirt detail, and whatnot, they were extremely expensive, and they didn't have to be. Didn't even have to be shadow casting. These were just kind of adding little, like you can see here in the slide, you can see some like piles of dirt and things like that. That doesn't need to be shadow casting. It's just like a very small kind of height increment. And so immediately I went through and just disabled these shadows on these large sort of dirt piles and things that didn't need it anyways. And that brought the shadowing cost down to 3 milliseconds for alpha point. And so, yeah, take away, the worst thing you can do for virtual shadow maps is have really large non-nanite objects casting shadows. That is the worst thing you can do. And so if you're having non-nanite assets cast shadows, keep them small, and ideally keep everything nanite as much as possible, because then that goes to the nanite shadow pass, and that's much faster. Speaking of nanite performance, really consistent. For an alpha point, it was about 2 milliseconds at 1080p input resolution, and kind of wherever I looked, it was always about 2 milliseconds. Of course, now you have to keep in mind there's the non-nanite base pass as well, and in alpha point that was about 1.2 milliseconds, and that included things like the character, right? Character is skeletal mesh, so that can't be nanite. Blended pixel depth offset, water and sand, grass, and then the vegetation, things like that. So things that can affect nanite performance are the material complexity and nanite overdraw. These are things to look at, and there's view modes for both of those inside the editor. So yeah, definitely something to keep an eye on. And again, like I said last slide, anything that can be nanite should be nanite. Even if it's a simple cube, just make it nanite. That's the best advice. And you can see here's some of the nanite view modes. There's the triangle view mode on the left, and then the cluster view mode on the right, sort of how nanite clusters assets. We added a custom VFX buffer, like I mentioned at the beginning of the talk, and materials can write into this custom VFX data to the G buffer, and Niagara can be aware of that and do things with it. So Niagara can spawn particles from a emissive material, like in this case on the door, and it's just so cool how you can see even Lumen's picking up on it, and it's changing the lighting in the hallway here. But yeah, this is really powerful. And we are definitely going to be using that a lot. So we added convolution bloom on console. The convolution bloom, again, is not a UE5 feature. It was added in UE4 and 4.16, but we love the look of it and wanted to add it to console. And so we've done that and did some optimizations. It was quite expensive at first at 7 milliseconds, but nowadays we're running at a quarter res. With some optimizations, it's at around 0.3 milliseconds and super viable. I believe this is now enabled on console in the newer versions of UE5 by default, and it's not something you have to modify code to do, which is good news for everybody. But yeah, really love the look you get. And you can see here on the particles coming off the door that you get kind of these star patterns coming off the particles. That's all convolution bloom as well, which is fantastic. This was a fun experiment that I did, kind of creating a FPS widget UI. Sometimes going through getting performance results on Gears 5, you kind of wait for QA sometimes to play the level and get that performance report. And I was like, could I get reports immediately for myself on how things are doing? So you can see here it's giving me my average frame rate, my average milliseconds, how over budget am I doing, and also stats we like to use is percent at 30, percent at 45 FPS, and percent at 60 FPS. So you can see those are updating here in the video live. So you can see I'm 21% at 60 FPS in this case, or 62% at 45 FPS. So yeah, this is sort of kind of fun. We'll sort of see how we deploy this at scale, but it really shows the power of what you can do with the widget UI and hooking into the system, the rendering systems. So ray tracing, since Alpha Point, and I spoke about Alpha Point at GDC, but since then we did some experiments with ray tracing, so I wanted to talk about that. So we have Lumen ray trace reflections and Lumen ray trace radiance cache in these screenshots here. And again, like I mentioned, ray trace reflections trace against the nanite proxy mesh. which is 1% of the nanite mesh. So it's an approximate, it's sort of a really low lot of it. But this keeps performance high. Or fast, I should say. And so you can see here at the top is sign distance field reflections, or the software path. And you don't quite get as much detail here, but again, it's still a worlds better than RCA's from UE4 and Gears 5. Ray trace reflection quality 1. You start seeing the proxy meshes come in, a lot more detail. Looks a lot better. You can see some texture detail. And then quality 4, which is very expensive, but you can see all that lighting and texture detail come in now, and it just looks fantastic. So Lumen ray tracing quality 1 costs about 6 milliseconds in UE5 early access, and quality 4 in my test was about 14 milliseconds. But this, I do know for a fact, this has been optimized considerably since early access, so these ray tracing numbers should improve over time. And a final thing I quickly wanted to mention is things like ray traced area light shadows. These can vary between about 2 milliseconds to 10 milliseconds, but these are viable replacements for things like virtual shadow maps for skeletal meshes, as skeletal meshes do not benefit from nanite shadow acceleration, right? So a virtual shadow map, say you have a cinematic and you have a virtual shadow map hitting a skeletal mesh, that's going to be fairly slow because that is not nanite. So if it's going to be slow anyways, maybe you may as well make that a ray traced area light shadow, and that will really improve the quality and be just slightly more expensive in my experience. So currently, as it stands, that's a good hard and fast rule. Okay, so Series X performance. Looking at Xbox Series X and Alpha Point with a target of 60 FPS at 1080p or 50% input resolution. Using TSR, of course, up to 4K. With all the features enabled, Alpha Point is about 46 FPS, 21 milliseconds, and GPU bound. CPU is fine, no problems there. And so very GPU bound. Most expensive systems are Lumen, Virtual Shadow Maps, and TSR than nanite. So this continues to get faster with workflow tuning and improvements from Epic and the coalition. So this, I'm pretty confident we will hit 60 with this quality. We're getting closer and closer, but that's kind of where we're at today. Xbox Series S performance, so you could target output resolution of 1440p or 1080p with Series S at 60 FPS. So the input resolution, we're still trying to figure out what the best case is here. But Xbox Series S definitely benefits from the TSR, given there's quite a gap there it needs to bridge. And the real issue of Series S is if your input res gets too low, TSR can't fix everything. You will see flickering and things like that. So you got to keep that input res higher than 50% in most cases, to keep Series S temporally stable. And so that's sort of the challenge there of Series S. We don't have all the solutions right now, but it seems very viable with just a few maybe tweaks to lumen quality or whatnot. You could just bump that input res up a little bit more, and then your Series S would look great. And CPU is not a concern at all on Series S. So Alpha Point learnings. UE5 is stable and viable for production, works great on Xbox Series X and S. We love Nanite and the predictable cost of it and just the ability to just churn through a crazy amount of triangles. It is a large area of workflow change for content creators with UE5, probably the largest. So we're still just kind of getting our heads wrapped around that. Lumen produces beautiful results in real time and really is fantastic. It's all just about managing the quality settings with Lumen to keep performance in check. Virtual shadow maps produce amazing ray trace-like shadows. If you have lots of large shadow casters that are non-nanite, you'll run into trouble, but if you keep things nanite, you will be okay. Content creator workflows are extremely important with next gen. It's just this content is really dense, and you need to have anything that can be streamlined should be streamlined for your content creators. And keep an eye on Series S input resolution and Series S memory. You got to keep an eye on that, ensure everything can fit. lots of best practices from there. Maybe in the future, the coalition will have more to say about that as we kind of get through projects. And we, need about a 25% GPU optimization with UE5 to kind of hit that solid 60 FPS with dynamic resolution scaling. And things seem to be on track for that with Epic's current velocity. And really, UE5 truly unlocks artist potential and allows artists to realize amazingly detailed worlds, which is really exciting to see. Okay, moving on. Character rendering test. This is a character rendering test we did in UE5 running on Xbox Series X, and I'll show you a video of that. Okay, hope you enjoyed that. So what is this character about? So again, that was all running on Series X. So he has 4 times the facial topology than a Gears 5 character. The body's about 3 times higher than a Gears 5 character. And the groom asset, which is beard, hair, eyelashes, eyebrows, is 250 times higher than a Gears 5 character. And you can see that there with the hair being 3.25 million triangles. And the thing that really struck me when I looked at this was looking at the eyelash at 3,500 triangles, and it reminded me that that was the character budget for an entire Xbox 360 character was 3,500, maybe up to 5,000 triangles in the Xbox 360 generation. So now that's in an eyelash, which is incredible. We did add peach fuzz as well, which was really fun. So how did we build this character? We did leverage MetaHumans for teeth and eyes and for the face topology and the materials. But we did build the face using DCC tooling. We couldn't quite get the look we wanted with MetaHumans, and we just kind of found like we got the control in the DCC tools. And we leveraged multiple detail maps, cloth shaders. It was all sculpted in ZBrush. We used our Substance Painter custom pipeline to Unreal and used 4K texture maps from Substance Source and Megascans. And we used Maya XGen grooming and Unreal integration with Alembic for the groom assets. Character performance. So this was interesting, and I have a few findings since my GDC talk. This character, we were able to render him on Xbox when it's just the character, but when you put him in a cinematic, that is challenging to hold 30 FPS with this, mainly because of this groom asset. And so currently the groom asset is 8.7 milliseconds. Epic has done some recent optimizations that should accelerate that. And some things that we can basically do is we need to lower the groom asset triangle count. Talk a bit more about that later. We need to add things like peach fuzz, LODs, and drop the peach fuzz at a certain distance. We found, disabling things like hair strand sky AO saved 2.5 milliseconds. Like I mentioned here, when we did a test of having the triangle count of the groom, that brought the 8.7 milliseconds down to about 5.5, and it still looks good. It still needs a bit of refining, but that was quite promising. We're also running the Burley SSS, which is 3.5 milliseconds or so in this scene. really cool to see the comparison here of Gen 4 versus Gen 5. And you can see just the detail you get in the Gen 5 character on the geometry density around the eye and the groom assets for the eyebrows and the eyelashes, the shaders, the burly shader, poor detail. Yeah, it's just incredible quality difference. So we grabbed this character, we had this environment, Alpha Point, we put them together and made sort of a cinematic tech test to evaluate performance and quality. And I unfortunately can't show you that cinematic right now. Here's some shots from it, but I can talk about what we learned from it. And so things like groom assets, when we had translucent materials in the scene, they wouldn't sort. They wouldn't sort properly. So we had to enable separate translucency in the project settings. And this affects things like TSR gets a little bit slower. And of course, there's a separate translucency cost. But that was necessary to have the groom asset sort. Yeah, we've set a new groom asset target of about 1.5 million triangles to try and run this on an Xbox Series X. And I think that's really valuable info. That took us a while to get to this number, but right now we feel like that's the sweet spot. But subject to change in the future, but that's kind of where the sweet spot seems to be for groom assets. Virtual shadow maps are expensive when casting on a character. So like I mentioned earlier, using a ray trace area light might be a better way to go. Depends. And for any Nanite assets, virtual shadow maps are the best way to go. Those are much faster with Nanite assets. We're loving Sequencer. Again, reminder, Gears 5 shipped on an old version of UE4 before Sequencer. So Sequencer is new to us, and we're excited about nested sequences and working with that. It's been fantastic. And really, it seems like kind of a no-brainer. Quarter res, there's a CVAR to quarter res your post-process. You should probably do that. That makes things like convolution bloom much more affordable, as well as all the other passes like lens flares and everything else. So highly recommended you do that. So conclusions. Overall, the sum of all the additional visual systems together in UE5 combined with the power of Xbox Series X and S really creates a noticeable visual leap from previous gen games. It's fantastic. We're embracing hybrid workflows, and that seems to give us the best results. Like we don't have to use MetaHumans for everything, but use MetaHumans for some things. We don't have to use Megascans for everything, but use Megascans for some things, kind of what they do best. And TSR produces amazing results even at low input resolutions, which is kind of a godsend. And ray tracing in UE5 does produce some pretty great results as of late, and performance is getting much better. And yeah, things like Lumen, ray trace reflections, and ray trace radiance cache, and then ray trace shadows as well from lights is really intriguing. And yeah, current generation of consoles come out of UE5 will fully unlock our artist potential, and games on Xbox Series X and S using UE5 will look incredible. So thanks to all these people. This wasn't obviously just myself creating a lot of this. There's an army of artists and engineers and lots of folks to kind of help us create all of this. So thanks to all these people for building all these fantastic assets. Thanks to Epic for the support of kind of coming together with this presentation. And we're hiring at the Coalition, so please join our squad. If you're interested at all, you can email us at coalitioncareers@microsoft.com, go to the website. And we also have a virtual booth here at MEGAMIGS that you can come and hang out at. And I'll also be answering more questions after this talk in that booth. So yeah, thank you very much. And hope everybody has a great day. Bye-bye.